Good evening and welcome to part 2 of lesson 2 on probability of the binomial distribution with me, Mr. Southern. Now in the first part of the lesson we looked at a cumulative binomial distribution example, purely looking at the notation, getting to grips with that and how to use the calculator. What I've got now is one with a little bit more context and words. We need to interpret the question, but the fundamental mathematics is the same as we did in example 1. So here we have a biased coin which lands on head 60% of the time. The coin is tossed 8 times. What is the probability of getting A, no more than 5 heads, B, at least 6 heads? So pause the video, have a go at yourself, and then see if what I do is the same as what you did. Okay, so first thing, binomial distribution. We know that because that's the title of the lesson. But what if this was in a different context? We're doing lots of different questions all at the same time. How do we know that this is binomial? Well, we know that there's 2 outcomes because it's a coin. You can get heads or you can get tails. We know that there's a fixed number of trials, 8. We know that the probability of success, which in this case is heads, is constant. And we know that each of these trials are independent of each other. So conditions for binomial are satisfied. So what first thing I'm going to write in part A is that x follows a binomial distribution NP. And for this particular example, n is the number of trials, which is 8, and p is the probability of success, which is 0.6. And by writing that, I know which distribution I'm using, and I don't have to keep thinking back, okay, what was n, what was p? I've got it written there. Now, no more than 5 heads. How many does that mean we're allowed? Well, we're not allowed more than 5. So we're not allowed 6, we're not allowed 7, we're not allowed 8. Are we allowed 5? Yes, we are allowed 5 because it says no more than 5. So we are allowed 5. So what we're actually searching for in this is the probability that x is less than or equal to 5. 5 or fewer successes out of our 8 goes. So we'd go to your ClassWiz calculator, binomial CD, put in the information. Helpfully, I've left mine on the table over there. Get used to this kind of stuff. I've now got it. So we're going to go menu, 7, down 1 to number 1, binomial CD. Use the list function, put in the number 5, and now n is 8 and p is 0.6. And if I type that in 4 decimal places, which is the standard, we're getting 0.6846 to 4 decimal places. Interesting aside, why is it 4 decimal places? Before the calculators that would do this for you, you'd be looking these results up in a table of values, and the values in that table were all rounded to 4 decimal places. So that convention has retained its status, as it were. Right then, part B, at least 6 heads. So 6 or more. So thinking about the number that we want anything from 6 to 8 heads is okay, which means that we don't want anything from 0 to 5. So to obtain the probability of at least 6 greater than or equal to 6, we would actually be doing 1 minus the probability of up to and including 5. We have that already from part A. So it's simply a case of saying 1 minus our answer from part A. So I'll store that value in my calculator, go back to the standard calculation menu and use that result, and to 4 decimal places I get 0.3154. So there we go. Binomial distribution, the cumulative function, a wordy example. Interpret what you're being asked for. Take care, if it's greater than a particular value, it's worth doing this. At least 6 was 6, 7 or 8. Think about what you don't want, because whenever we're doing a greater than or equal to, we're having to do 1 minus up to and including a certain point, because because that's what the cumulative distribution calculates for us. So in this case, we took away the probability that x being up to and including 5, and job done.